In today's topic is about stack and queues. We will talk about the structure, operations, and their implementation using arrays and linked lists. What are stacks? Stack is a data structure in which inserting and deleting items happens at the top of the stack. This is referred as LIFO or last in, first out, wherein elements that is added first will be deleted last. This is a representation of structure of stacks. Insertion and deletion happens on the same end, that is the top of the stack. Operation of stacks. Some basic operation of stacks are push and pop. Other operations include pick or top, is empty, and is full. Push. Adds an item into the stack. If the stack is full, then it is said to be in an overflow state. Pop. Removes an item from the stack. The items are popped in reverse order in which they are pushed. The stack is said to be the underflow condition if it completely empty. Pick or top. Returns top element of the stack. Is empty. Returns true if no more items can be popped and there is no top item. Is full. Returns true if the stack is already full and no more items can be pushed. In stacks, the difference between array and linked list is that each element assigned to a slot and has fixed number of elements, while their similarities are the reference variable and same method of keeping track of the top position. In this line, the initialization function we will be putting the list that would act as a stack database, and that function would simply return the number of elements inside our stack database. This line function would act the user desired element into the stack. This stack function would take the element that is the top of the stack and would be the element that has last inputted. And from outside the class, the first line will be using the class and stored in the stack variable. Then we will be asking the user to input whatever he wants into the stack. Finally, the last three lines will display the output of the program. What are queues? Queues is a linear data structure in which an element is added from one end called the rear, also called the tail, and the element removal happens in the other end called the front, also called the head, which means once a new element is inserted into the queue, all the elements inserted before the new element in a queue must be removed. To remove the new element, queues follows the order FIFO or first in first out, which is the reserve of the LIFO or last in first out in stacks. In queues, the least recently added element with the first one to be removed. This picture represents the structure of queues. Here, we see two ends called the rear and the front. Adding of the elements takes place in the rear while removing the elements happens in the front. Thus, the FIFO or first in first out is implemented. Basic operations of queues are in queues and the queue. Some functions include pick, initialize, is empty, and is full. End queue stores an item to the end of the queue. DQ removes an item to the front of the queue. Pick gets the value of the first item which is the front of the queue without removing it. Is full, like stacks, checks if the queue is full or not. Is empty, like stacks, tests whether the queue is empty or not. In queues, the array has fixed size give impression that queue is full, while the linked list, the queue is never full. In this line, we will be initializing the list that would act as a database of our queue. The enqueue function is solely dedicated in adding elements into the queue, and within the dequeue function, there's a condition that errors would be prevented if the user tries to dequeue even if the queue is empty. The count function counts the number of the element in the queue. And from the outside of the class, the first line will be initializing the queue class stored in queue variable. Then, we will be adding the user desired element into the queue. Finally, the last three lines will be display the output of the program.